Hey everybody, and welcome back to Algebra 2 online. So the plan for today is to talk about rational root equations. So we've really seen stuff like this already, but I wanted to do a few more things where you're going to see some kind of weird rational exponents popping up in the root equations. So things like 2/5 power and stuff like that. But to get started, I just kind of want to do a problem that I think is kind of looks scary, but ends up not being so bad once you kind of think about it. So it's a root inequality, like our last video. And basically, n here is just any even positive integer. So this answer would, for this problem, would be the same if it was, a square root or a fourth root or a sixth root or a 20th root or something like that. And we're just asked to basically solve for, x such that this thing is less than this thing. And if you try a graphical approach, it's kind of neat because it's basically a much quicker way to do a problem. So let's say this is yellow, and let's do this in green or something. So if I sketch this out using function transformations, right, we know this one is going to be shifted to the right 2, flipped, and then shifted up 1, right? So we're going to go over, let me tick off some of these, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So we're going to go over 2, from the origin, and then we flip it, so it's upside down, but then we shift it up 1, right? So we're going to get some sort of function that looks like that, just based off of what we know about the shape of nth root functions. For the other one, we shift it right 2, we don't flip it, right? And then we just shift it up 2 from there. And so it's just kind of an upright kind of curve like that. And, their curvatures would be the same based on whatever n is, just if it's, one that's to the, fourth versus 6, you're going to get a little different curvature, but it'll always mirror itself here because it's the same n value. So based on that picture, right, question is when is this thing, this green one, less than this yellow one, right? And you can see that it's basically always less than it, except that they're not always defined, right? The domain, if you just set the inside greater than or equal to 0, you get greater than or equal to 2. So the answer to this thing would basically be, because the domain is greater than or equal to 2, and the inequality part, we'll just say, looks like it should be all reals, right? Because the green one's always less than the yellow one. If you meld these two together, right, then the final answer would just be greater than or equal to 2. Anything greater than or equal to 2 is going to keep that green one less than the yellow one. All right. So these are the kind of things I'm talking about that I want to take a day to look at a little more closely. So a lot of problems in math boil down to these kind of weird rational root equations. And you got to know how to deal with them. And basically, if you have something like a 3/2 power, right, we've seen that that's two things. It's either a square root, or the 1/2 is the square root part, and then it can also be understood as there's a cube root, or a cube, going on there. So you got two things, square root and a cube, okay? This one, cube root, and then power of 4, okay? And what I just want to do here is talk about the domain of these kind of different things, okay? I don't want to solve these out because they actually take a little bit of time. I will say a little bit about how we solve them, but so on this one, okay, this one would actually, you would have to be careful about domain, okay? This is the more annoying one over here versus this example over here, because you have a square root, right, with that 1/2. So you need to do the whole set x minus 3 greater than or equal to 0, So x is greater than or equal to 3. So that's going to be the domain. But then you have to go and deal with the cube root. So like the first step that I would do is maybe get rid of the root. So if I get rid of the root here, right, I'd square both sides. And then I'd have x minus 3 cubed equals 27 squared is 729. But then I'd have to do I have a polynomial problem now, right, where I multiply all this stuff out, and you should, right, get basically 3 solutions, okay? But, some may not work because of that whole domain restriction, all right? And so if you were solving one like this out, you would basically need to do all this out and then check your answers, because anything that's not greater than or equal to 3 won't work to solve the equation, right? This one is much nicer. Here, there is no domain issues because it's a cube root, right? And so we know that cube roots are well defined. They basically, a cube root looks something like that. There are no domain restrictions. You're not like cutting it off somewhere and it only is defined from there over. Perfectly good function defined everywhere. And so that one you wouldn't have to worry about the domain. So that part you should always know just by looking at the equation right off the bat. This one, because there's a 4 there, that means that you should get 4 answers. And they should all work. You can always check them, right? Because it doesn't hurt to check things, right? But I just wanted to talk here about which ones you need to be more careful about. And you would need to be more careful about these ones than these ones. All right, so for the most part, they're fairly straightforward. Like if I go back here, like you definitely can all solve this out. It just takes a little bit of time. You would get your 3 answers, and then you check them. Here you just, minus 7, divide by 3, and then I would cube both sides, and then you'd have to multiply this out 4 times. Not horrible either, but definitely a little bit of work. This is one, though, that you'll sort of see stuff like this, and it's not super obvious. So this is one where I think is really worthwhile to stop, pause, and ponder about the best way to do this thing. And if you take time to do that, you hopefully will stumble upon that it has the same sort of structure as some other stuff we've seen this year, okay? Namely, quadratics. It's got 3 terms, and that it has this nice square here, and then power 1 there. So there's kind of like an embedded quadratic here. And you also have this nice thing that 2/3 is double 1/3. So you can do the U sub trick that we've seen a few times already this year. That would really be the best way to solve that one. So I'm actually going to do this one fully out. I'm going to let U equal x to the 2/3. So then U squared is x to the, I wanted to say 1/3, right? So then U squared is x to the 2/3. Good. And so I'm going to convert this problem to 2u squared plus 5u minus 3. And you basically just need to do quadratic formula. You get negative 5 plus or minus 25 minus 4 times 2 times negative 3 all over 4. And then actually probably could have factored it too, because these numbers are pretty nice. But you're getting that u equals 1/2 or negative 3. And so u is x to the 1/3. So I'm going to pop that back in. And then you can just cube both sides. So you get an 1/8 for that one, or you get negative 27 for that one. And if you think about it, you should always want to check answers, right? in any of these root equations, but this is a cube root, so whatever we get really should work. I mean, you can go and check it. You can go and take these things and pop them in, but it's going to work because they're an odd root. If this was like an even number, I'm just going to say, I was going to think of one, but just some even number root, right? Then you would have to be more careful. But here, odd root, you can just circle the answers. Those two, they're both going to work. And that's really it for these things. So these equations with these kind of weird rationals, they don't get much weirder than that. A lot of them are basically on the level of like this problem right here. And it just takes some time to do it, but you can just crank through all that multiplication. I would always recommend you get rid of the root first. So even if it's a cube root or a square root, just get in the habit of getting rid of the root first and then leave yourself the polynomial so that you can kind of remind yourself how many answers you're supposed to get for each of these. And then don't also forget that if it's an even root, you're going to have to be more careful, and you're going to have to check the domain part for those. Or just check your answers against the original equation. So you can get your 3 answers and just plug them in and just see which ones work.